So, questions from last time? No? So, you had a homework to submit, right? The deadline passed? You all submitted? Grades for quiz 2 have been uploaded? Not yet? Okay. I will be sure that he will do today. I have them here, so I will give them to you later. Okay? Quiz 2 grades. Engineer Ahmed he has them already scanned, so he will upload the grades and the key on the blackboard today, inshallah. Okay. Do you want to have another quiz soon?
Yes.
When?
Right before the holiday. Okay, when's the holiday?
But no. When is the holiday?
19th. Wednesday, so it'll be.
So the holiday is on 19. So 19 we will not have a class? No lecture on 19? Sure? Okay, then. Then we will have a lecture, today's lecture, Wednesday or Monday, before the break. After the break, we will have it on the 1st of May. 1st of May is a working day. So 30. You'll start 30. You will be back. Okay, خلاص. Then your options to make the quiz are different. Today maybe, yeah, but no, Wednesday, no quiz. Okay, so we could have them on the 17th, so next Monday, or the Monday after the break, or the Wednesday after the break.
How many quiz do we have in total?
I have no idea.
I was going to say.
Guys, why you are late? 0 second it should be. How many quizzes? I don't know.
It's 19th holiday.
19th holiday? This is what your colleague they were saying. I'm not sure. Double check. I really have no idea. So check the calendar. It is published. The right QU calendar. So check there. When are the official dates? So which option do you prefer? These are the three options. 17th of April, 1st of May, 3rd of May. Good? Questions before you have to vote, okay? Questions? Any clarifications? How many quizzes? I really don't know. It depends on how we proceed. Good. So who wants on the 17th? Raise your hand. Okay. Who wants on the 1st of May? Without counting. Who wants on the 3rd of May? Why you are late, guys? So who wants on the 3rd? No one? So first? Good, we agree. First. خلاص 3rd of May, it's decided. We cannot be changed. 1st of May. Good? Okay. So you said first, right? 1st of May, so mail. Okay. Oops. Cool. Good. Included material will be from CDMA until until the last lecture. Okay, there will be more than 1 week. So no, that will not count. So today's lecture is included. Wednesday lecture is included, but next Monday lecture is not included in the quiz.
So only 2 lectures? No.
Everything from CDMA until next Wednesday. Okay. Good. So yeah, this is done. Questions before we start? No? Hussein. Oh, Irzam. Okay, so let's make a small review. Small review. Okay, let me see what we reached. Good. Okay, so last time we said that we will always want to increase the data rate for the wireless systems, okay? Wireless system researchers are always working to improve the data rate. Well, definitely the wireline people also, they are not any stand still, okay? Also wireline researchers are also working to increase the data rate. Probably the wireless will never reach the wireline. The wireline in performance is always better, but the wireless can provide something that the wireline cannot provide, which is mobility. Good. So our objective is to increase the data rate, which is this one. So we can download faster, we have more applications, and so on. And this is the equation in order to do it, and these are the parameters in order to increase. So if you would like to increase the data rate, we will increase bandwidth, power, or SNR, or any combination of them. Okay, first of all, this power, as we said last time, it is transmit power. So here, this is at the transmitter side. The SNR is the received quality at the receiver side. So here, this is at the transmit side, transmitter power, and here, this is at the receiver received power. Good? Yes. Good. Question, okay? Today from female. So where is the effect of the channel? If you have a good channel or bad channel, where this will be seen here in the equation? In the received quality. So here, you transmit the signal. You don't know how is the channel before you transmit. You transmit with 1 watt, 2 watts, 100 million watts, whatever is the signal, okay? And at the receiver side, based on the channel, they will receive a good channel or a good signal based on the channel, or bad signal based on the bad channel. Good? We commented about how to increase each one of them. We saw that to increase the bandwidth is simply not available, okay? It might be, or it is very expensive. To increase the transmit power, it will generate interference, so heat, to health, to blah, 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 battery. To increase the SNR is something that is really complex. Good? Because here also we saw, I see here that we saw the noise power. So the SNR is the relation between the desired power to the noise power. The noise power, it is simply untouchable. Good. So this, then you have to increase the desired power. How to increase the desired power? There are ways. They are usually complex. I think last time we said that in case instead of giving you 1 antenna, they will give you 2 antennas. This way, it will increase the amount of power that you will receive. Good. But yeah, that will in all cases it will consume resources. And based on that, then what do we agreed? Okay, on which one to increase among these 3? We said bandwidth. Why? Well, first of all, the feasible option. But yeah, the issue is it is expensive. What we said, the bandwidth is very expensive. Millions. So what do we care, ya Khaled? Barakat. Where is the other Khaled? I agree. So I suggest you put a complaint to the head of the department. The security is not a decision maker. Talk to. I cannot move. Okay, so talk to the head of the department, send an email saying that the room is without AC. Now maybe it's still acceptable, but after Eid, I think it will be really hot. Okay. So I was asking Khalid. No answer? Khalid.
I think it could be like more feasible than the phone.
But it is more feasible. But yeah, we have the issue with the price. What to do with the price? What? How? That's it. So here, what you will do, what the operator will do, okay, they will say, okay, how much it will increase on us, the cost of the bandwidth? 10 million real, what we will do, we will increase the cost, okay, on the customers. Okay, this way they will collect the money. And this is what I always say, that to have an operator is the best business. Why? It will never lose. It's always a making machine. Come. Sorry? Yes. So after you graduate, you can have your own operator. We call it Husseinkom. Mm. Good. So again, so here, what is then our first option and feasible option to increase the bandwidth? Last time I remember also I showed to you a slide from EM course whenever the spectrum was overcrowded. Do you remember? Okay, so then what to do? Okay, whenever it was overcrowded, the only option is to go to higher frequencies. So if we go to higher frequencies, whenever we move to higher frequencies, there is more available bandwidth. And here, this is sometimes something that makes students make complaints, okay, to make mistakes. Whenever you increase the frequency, not necessarily you increase the bandwidth, but now at least at higher frequencies, there is more bandwidth. What is the idea of frequency and bandwidth? Always I put the example of land. So here Doha. Okay, so let's say I put you an example with generation so you can get it more as a concept. So
Example about what?
about the bandwidth. So in 2G, okay, the system was operating at 900 megahertz. In 3G at 1800 to 2000 megahertz. 4G, they went to 3.5 gigahertz. 5G, they went to 6 point something gigahertz. 6G, they want to reach the 100 gigahertz. Increasing the frequency here, there is nothing on the frequency on the equation. Okay, here it is bandwidth, not frequency. But whenever we go higher on the frequency, we can find more bandwidth. So here we might find more bandwidth. And as I said before, the best example, or at least this is the one that I always use, is for a city like Doha. Okay, you want to buy a land, 2,000 meter square land. Okay, 20 years or 30 years ago, it was feasible to find that such land in downtown Doha. Good. Then after 10 years, downtown Doha was crowded, so they had to move away from the downtown. Okay, to let's say Rayan area. Then 10 years later, even Rayan was overcrowded. Okay, then they had to move to Slal. Okay, maybe after 20 years, Slal will be full, and they have to go even further. Okay, so this is the similar one. So whenever they always prefer something that is lower in the frequency, but yeah, there is nothing bandwidth there, so they have to go further. Okay, into the frequencies. Hopefully, there will be some band there for their bandwidth. Cool. Do you like the example? Yeah, hopefully it is clear. So this is the idea. Whenever you go higher on the frequencies, most probably you will find more bandwidth there available. But why we don't like to go higher on the frequency? So and whenever we compare to the example of the land, whenever you go further from the city center, everything will be far to you, right? So you will not really would like to go to live in what is the word يعني الشمال مدينة الشمال, yeah, very far, even it is cheaper. Or definitely you can find a land of 20,000 meters for square for you, okay? But yeah, you don't want to do that because it has a drawback. Good. What is the drawback whenever you increase the operating frequency? No.
The availability.
The availability, we say it is available. So this is good. The cost of what? No, the cost of the frequency, no, even it will be cheaper. It's like exactly, it is like the land. If 2023, you want to buy 1,000 meters square in downtown Doha, you have to pay millions, okay? Away from Doha, it will be cheaper. So here the same. If, for example, now an operator, they go to CRA and they have a band at, let's say, 800 megahertz, they will sell it for millions. They will say, well, we have a lot for you. Millions for a band at the 800 megahertz. A long story. Good. So whenever a higher frequency, more availability. Problem يا أبو عسال. What you said before? Complex devices. So whenever we increase in the frequency, we will increase the complexity of electronics. Example, you all finished here the lab of circuits 2. What was the operating frequency? Do you remember? 60 hertz, لا, a bit more. Generate a sinusoidal function of 1K usually, okay, is the number. Okay, so 1,000 hertz. So usually the number in the lab is 1K. So why you never generated a 1 mega?
Because our generator.
No, the generator that we have in the lab, it can generate.
The scope cannot see it.
The oscilloscope can see it. The components that we have, they cannot deal with that. Why? QU budget. But even of that, okay, even if you have budget, we will not buy more expensive components. Why? What? Mechanical? What's up? You have more budget, and still you will buy this one. Why?
It's cheaper because you don't break it.
Yeah, good, yeah, good point. No, so that you deal with the components that they are in the market. Okay, so even in some of the equipment that we have in the lab, yeah, we are away from the course. Okay, why we don't update them that frequent, and sometimes they are not that good. We know that there are something that is better on the market. Why we don't upgrade them that frequent? Because they are the ones that you will see on the market. Okay, it's not guaranteed that you will go to the market and you will work with the best equipment. Okay, maybe the equipment that you will deal with in a company, it is not that new. So this is why it's good that you deal with them.
It's harder to find as well electronic components.
And
Like the board we did for a bit.
okay, good. So again, so electronics. So here, whenever we increase the operating frequency, we increase the complexity of electronics. For example, and this happened to me. So 100 gigahertz, 2019, I searched not only in Qatar, worldwide, I was not able to find components, okay, that will work at the 100 gigahertz. 2023, even 22, from last year, I started finding, okay, some of these components. So moving to higher frequency is always challenging for the electronics. Even whenever you connect for your SDP, okay, if you want to do your graduation project, you have to be careful on which frequency to select. Very easy circuit with a source and a load. If you increase the frequency, you will have the effect of the capacitance to ground. You have seen this one. What is the capacitance to ground, ya Muhammad Noor? You have seen it, right? Why ليه كنت تعمل هيك براسك؟ Okay. What is the capacitance to ground effect? You should have seen it in electronics. Okay, so here, when we always have like this capacitor here. Whenever you increase the operating frequency, okay, this will become as a short circuit. So all the current will go like this and nothing will be delivered to the load. Okay, so whenever you start increasing the frequency, you have to be careful about how you design the circuit. Otherwise, you will have a short circuit and you can measure nothing. Good. This is why always to increase the frequency is you have to be careful. Increasing the frequency to reach this one, it will increase the complexity for the electronics. Definitely, it will increase their price and cost. Cool. Clear to all? You follow us? Sure. Good. So I was where? Okay. Good. So this is related to the bandwidth. So first of all, we decided that we will go to increase the bandwidth. Good. Whenever we want to increase the data rate, most probably our key option, it will be to increase the bandwidth. Let's see now, whenever we increase the bandwidth, what will happen? Before that, questions? Khaled? Lost? Sure? Khaled? Oh, I was searching for the other Khaled. So the wireless channel is, it is random, unpredictable, because it is random, changing. Even if this is frequency or time, it will be changing all the time, right? But even it is changing and it is random, we can say that for a short time or band, we can consider to be fixed. What we call this one, yeah, Ahsan. No, he is who? He is Rasul. Ah, who is Ahsan? Ah, صح. He is missing. Rasul. What we call this small band or frequency whenever it is keeping the same performance. Muhammad Anwar. Who is that? Batarani not here. عبيدة. احلف. I will put you missing عشان you answer this. Saleh. Coherence. So here we call this to be the coherence. If it was on the time axis, we call it coherence time. If it was on the frequency axis, we call it coherence bandwidth. So again, what is the coherence? It is a small time or band whenever we can consider the channel to have the same performance. Good? Coming. So here, this is whenever we make zoom. For this one, it will be like this. Whenever we increase the bandwidth, so instead of having, this is whenever you have a small bandwidth. You see, here you have a small band. This is the frequency axis. Whenever you have a large band, this is what you have here. This is large bandwidth. Comparing the small bandwidth to the large bandwidth, what can you say about its amplitude or power?
More power. The same.
Small bandwidth. Small.
No, it's the same power.
The same.
What I can conclude is that whenever it is small, so here the value is very close to each other, so I can say it is the same value. Whenever it is large bandwidth, here I cannot say they have the same value. Its value is very variable. Do you agree?
Yes.
Okay. Let's see how this could be a problem. Yeah, I will. This is called frequency flat. This is called frequency selective. I will come to them now. Before that, let's come to here so that I explain. I'm trying to motivate why this could be a problem. This is the most famous equation in communications. Okay, y equals hx plus n, where the y is whatever you receive, the h the channel, x whatever has been transmitted, n the noise. Good. Be careful, and this is a common mistake by students. They put it like this. This is not, okay? And such a mistake means you have no sense. Okay. So what is the idea here? First of all, where the noise is added, based on this equation, but based on what is written, where is it added? That's it, after you get the signal. So here, This is what you transmit. So imagine that this is the channel. This is here. Whenever I want to transmit, I transmit X. X will go through the channel. So here at the receiver, I will receive HX plus the noise is added. So first of all, noise here added at the receiver. We said it last time, okay? What is the reason that we have noise? Why we have noise? Yeah, Shihab. No, but good that you raised this issue, so I comment. Why do we have noise, yeah, Abdul Ghani? That's it. So we will have a noise here, this additive wide Gaussian noise, because we have electronics. So as long as you have any electronic component, immediately you have, this is what we call the additive noise, okay? And we always have electronics. So here, this is your device, whatever is the receiver, this laptop, whatever, okay? It has transistors, nano transistors, but they are transistors, okay? So immediately, whenever you receive the signal, the noise will be added. So how to remove the noise? Filter? No. Higher quality of what? Whenever you have higher quality of the component, you will decrease the noise. I agree with you. But how to remove the noise? Very good, yeah, Yusuf. Here, add here, you can not remove the noise. You can decrease its effect. So here, you can, well, I can write it here. You can decrease noise effect, but you cannot remove it as a noise. How to decrease the noise effect? Something that we have already seen in this course to deal with the noise.
We have to put the components like 90 degrees.
To put the components 90 degrees.
No, I remember something you have to put 90 degrees.
What
What if we increase the power of the transmitted signal? Increase the power of the transmitted signal.
We said that increasing the power will consume more of the battery, it will generate more heat, it will destroy your head, or it will generate more interference. So no. Feedback? What is this? How to decrease the noise effect based on something that you have seen already. So you will have an effect because of the noise, but even of that you can compensate. No. Sorry? Code? Code of what? No. We have seen the channel coding or encoding. So instead of we send 1, you send 1, 1, 1. So because of the noise, maybe you will receive it as 1, 0, 1, but you will say this is equal to 1. So here you have a noise. The noise has made an effect, okay? So it had changed one of the bits that you have transmitted. So it made you to make a mistake. But thanks to the channel encoding, you overcome. So you remove the noise effect. Good. So here you can decrease the noise effect. For example, the channel encoder. The repetition encoder. Yes, could be one of them. Good. But you cannot remove the noise. So here you can decrease the noise effect, or you can remove even the noise effect, but you can not remove the noise.
What's the other encoder? What's the other encoder you said?
Sorry again.
What's the other encoder?
He said repetition. So the repetition is a kind of channel encoder. Good. Clear this point? So again, you can never remove the noise, but yeah, we have ways to remove its effect. So it will be there, but it is not affecting us. Good.
What do you mean? You can remove noise effect. You cannot remove noise.
Yes. So you can remove its effect. So it will be there, the noise. Here you see it is there. It made you to make a mistake, but its effect was cancelled because of this repetition. Good.
So the
Disturbance is more mechanical. No, coming to noise and interference. Okay, the noise can make you make errors. Okay, but not necessarily. So, what is the difference between noise and interference? Noise here due to electronics. Interference due to what? Other users, systems, but yeah, others. Good example. You are talking to whatever it is not communication wise. I'm talking to Hudayfa, and Ubaida is talking to Abdulaziz. Okay, so he will hear me whenever I'm talking. We are talking at the same time. This is interference. Okay, communication wise. Okay, whenever you hear this is whenever we said about the CDMA. If they are not gold codes, okay, then there will be some interference. So the background there will be like there is something in the background. Okay, the quality will not be that high. Other examples, yeah, between systems, for example. Have you ever heard the phone interference on FM radio?
Yes.
How?
When you, what's it called? When you get close to a certain, like let's say on your car radio, you're listening to you're just listening, and then if it comes close, it just it cuts it because it has the same frequency, so you just hear it a bit.
What do you hear?
The call.
You hear the call, so what the others are talking?
No, like it's like a brief moment and then it cuts.
Yeah, how it will sound?
Increase the volume.
Again?
I will not touch it.
No, we need this. So yeah, we are joking. Yeah, again, one more time. Okay, fine. So what is the idea? I maybe okay. You had this issue, whatever your colleague is saying. So whenever you have the FM on your car, okay, and you are driving, and you have your phone next to the radio, sometimes before you receive the call, okay, you hear that the radio is making some noise or sound, as your colleague said. Okay, what's happening? There is an interference between the signal coming from the radio with the signal on the FM. Good. So this could happen between the two systems. So here, this is whenever we have interference between users, systems, or whatever. This one, yes, can be cancelled. So interference can be made equal to 0. How? Orthogonalization, okay, if they are users, okay, or proper filtering. So here, how? Through engineering proper design. So if you make the design to be fine, correct, okay, you can reach 0 interference. But again, so here, noise and interference, they are not the same. Interference, you can completely remove it. Noise, you cannot remove it. Good. So where is interference here in the signal? Y equals hx plus n. No, interference, it means this is that you are receiving the signal of another user. Right? Whenever we say interference, then there is something else interfering on you. So where is it here in this equation? No. No, it is actually nowhere here. It has to be upgraded. So if I want to introduce the interference, it has to be y equals, let's say, your signal x1 plus the signal of another guy plus n. This will be the interference. Okay, so I am, so this transmitter, this router is sending signal to Ubaida and to me. So if there is interference, it means that I'm getting some of Ubaida signal, okay, interfering my signal. So it will be, this is for Ubaida, but I'm receiving it, I should not receive.
It's about an FM and the telephone, like the city, they have different like bandwidth, right? So why they
different frequency?
Why they have interference? They have different.
Good question. What is the operating band for FM? فخرو. FM frequency. Do you hear the FM radio? Which track do you hear? At which frequency is it? Good. 94.6 what? That's it. So here. This is the one. From your radio, from which frequency to which frequency? Have you ever seen? 88 to 106. So this is more or less. So this is the FM band. Good. So what is the, let's say for the easiest, GSM band? I just wrote it today. All right. Yeah, لا مش females والله هون. Good. So 900. So the operating frequency for the cellular, where is it? Is 910 to what? 990 if it is both uplink and downlink. Again, megahertz. Are they close to each other? At all. They are very far away. How is there that there is some interference, ya Muhammad? Muhammad, right? Or Abdullah, sorry. How is it possible that there is some interference here? لا. Okay, I will tell you what happened here. Actually, whenever they made the design, they made a mistake. All right? What was that mistake? So they said, okay, from 910 to 920, okay, let's put a filter. And they came up with this filter. Good. They designed the filter, okay? Well, the filter looks nice, everything good. Well, perfect, good. So we are fine, okay? Whenever they went and they implemented this one, okay, and they started selling the device, they realized there is an interference. Then they went back to the lab to check, okay, on this filter that they designed. They realized, because then whenever they designed this one, so they checked at 900.05 or 995, everything is good under the conditions, we satisfy the requirements. This filter, whenever they design it later, whenever they check, they realize that is making this. Okay, so the filter definitely was not ideal, okay? And there is a peak. This peak is hitting the FM band. There is another peak here, but yeah, it is not commercial. So yeah, it generated peaks that they were generating interference. What to do? لا حول ولا قوة. The devices have been already sold. The standard has been already closed. They said, okay, خلاص deal with it.
Change the bandwidth.
They cannot خلاص يعني they already issued devices, okay, or issued the standard, so to change it was not easy at all.
Why the filter?
Sorry?
Why the filter?
Why the filter? So here you have a signal. So imagine I'm sending a cosine or sine or whatever. So you need to filter. So if there is anyone here, another system, you don't interfere on it. How they guarantee that? Because here, if this is the spectrum, this is the frequency. So we have so many systems running like this, right? Like the figure I showed you from EM. So here you have a system, or here another system. So how to distinguish between them? This one will make a filter, this will make a filter, or this will make a filter, or this will make a filter, and so on. The filter that they made for 2G, it was not perfect. So it generated these two peaks. You all studied here the course of filtering?
No.
Now? Which chapter are you now? Still?
We didn't reach to digital signal processing yet.
لا حول ولا قوة. Who's teaching? Okay, good. So he will reach, whenever you will see the filter, something called FIR has been explained. FIR filter design. Okay, so in the FIR you will see, then there is something called IIR. He told you that they will be explained. So this filter is designed IIR. Okay, so and whenever they design, they generated the two peaks. Cool. Answer, Hisham. More questions? Sure. Seems that you have. Okay, clear. Okay, good. So this is then the signal. Okay. Ideally, what you want in a communication system. So whenever Hudayfa is calling Ubaida, okay, and he says, "Hi, how are you?" Ideally, what Ubaida should hear? Okay, so ideally, we need the Y equals the X, right? So whenever you send, you hear. Whenever you want to download from YouTube, it is actually downloaded. Whenever you want to send to Snapchat, it is actually sent, right? By the way, whenever you download from YouTube, who is the sender? Ahmed Munzer. Whenever you download from YouTube, who is sending? Who is the sender? We need transmitter, receiver. You are the receiver because you are receiving. Who is transmitter? يعني الفيديو في التاور off. That's it. So whenever it is not the guy who uploaded, who put it on the server. Okay, whenever you download from the server, the transmitter is the server itself. You are as the receiver. Good. By the way, also because it was asked today, who owns YouTube? Do you know? Good. Who owns WhatsApp? وانستغرام كمان. Okay, good. Bill Gates? No. Yeah, okay, good. Good, you know. طيب. So, this is our objective, to make the y equals to x. Looking to this equation, what you need to do to make y equals to x? First of all, to subtract n, we said that you cannot remove the noise, but yeah, it is there, so you can do nothing, okay? But yeah, it is there. What else you have to do? Divide by what? Divide by h. Why? So you need to remove this h, so you need the y equals to x. To remove the h, it is an operation that is called to equalize the channel. So to equalize the channel is to remove the channel effect. Whenever you divide by h, what you are doing is to equalize. So what is the equalizer? Do you have an equalizer? Yes, sound equalizer. Do you have a sound equalizer? Where? No, we need something heavy. Anyone has a system on his car? Sound system? No one has a sound. After Ramadan you will put it. Okay, good. So some of our graduates here, they actually work as sound engineers. Okay, so because we check always. So many companies for sound engineering. Okay, definitely they implement. So yeah, they would like to make an event. Definitely, whenever you put speakers, it is not plug and play. Okay, yes, you have to put the speakers. You have to check what is the impedance for the speaker, how to connect more than one speaker, and put equalizers. Okay, so the equalizer, they will remove the channel effect. Where is the channel whenever you connect speakers or subwoofers and so on? عمر انت الوحيد يا عمر. So whenever you put a system with speakers or subwoofers, okay, and I said that they need an equalizer. Why they need an equalizer? So where is the channel whenever it is a speaker or subwoofer and so on? Or amplifier is another device. Yeah. Where is the channel? The wire. So they don't have wireless. Okay, it's a wireline communication system. So where is the channel? Is the wire itself. So they want to remove the effect of the wire, so the voice or the sound will be much better. Clear? So they need an equalizer whenever they connect subwoofers or speakers and so on. So they remove the effect of the copper inside the wire. so that the sound will be much better. Good. So equalizer means to remove the channel effect. And here, okay, to remove the channel effect on this one, as you said, we can divide by h. If I divide by h, then here this is clean. What happened to the noise? It is affected. Okay, we call it modified noise, but yeah, it is still noise. And it was additive wide Gaussian noise. It will continue to be additive wide Gaussian noise. Good. Now let's see here on this one, what will happen whenever you have a bad channel. So imagine the h equals 0.1. What will happen? Saleh, that's it. You are amplifying the noise. This is why whenever we say, whenever you have a bad channel, the detection will be bad. Why it will be bad? Because from the equalization, you will increase the noise effect, then it will destroy the system. Clear? Clear to all?
What does insulation do then?
Sorry?
I have a question with the insulation. Let's say if you insulate the place, that also fixes the noise. No, the speakers. Right?
It's another story. If you want, we can talk after class. Good. So at this point, so whenever you have a bad channel, actually you will amplify the noise effect. Okay. So and this way here you will have it clean. This is our objective. Good. Clear. Clear so far. Okay. Let's see how here I want to divide them by h. Let me go back. How much is the h here whenever I have a small bandwidth? How much? Yeah, more or less. Keep 3, Ben 5 or 10. It seems 8.5, 8 point something. Okay. How much is the h whenever you have a large bandwidth? You don't have a value. It's a variable. So here it's a variable. It's not a fixed value. Then, and here comes the motivation for this chapter. Where can I write it? Let me, we can put it here. Let's start, okay? We said that we want to increase the data rate. Why you want to increase the data rate, Hussein? No. You can download more stuff. So you want to increase the data rate. To increase the data rate, which parameter we said that we will use? Yeah. Fakhro. In the data rate equation, we have 3 parameters. Which one we said we will select? SNR, ولا power, ولا bandwidth? Bandwidth. So here we said that our technique or tool will be to increase the bandwidth. If we increase the bandwidth, what will happen to the channel here? This is whenever we increase the bandwidth, so our bandwidth is large. It will become, this is called frequency selective. What does it mean frequency selective? So it is for each frequency, it has a different performance. For this frequency, for this frequency, for this, each frequency has a different performance. Here, we call it frequency flat because all of them, they have the same performance. Good? So, where is my chain? No, here. Whenever I want to increase the data rate, I will increase the bandwidth. If I increase the bandwidth, the channel will be frequency selective channel. Whenever it's frequency selective channel, what is the problem? Here, you can not equalize the channel. Do you agree?
We have to transmit y over h to receive x.
No, you will transmit x.
Divide by h.
You will receive x. So yeah, sorry, you will transmit x. You will receive h x plus n. After you receive, you divide by h. You see here, you multiply 1 over h, multiplying y. So once you receive, you multiply. So here, who is doing this? The receiver. You see, the receiver has to make some channel equalization. No?
No, I hear about the equalizer. It's like a sampler.
What is the equalizer?
Equalizer before the sampler, yeah? Or after the sampler? Sampler. the communication channel.
The equalizer is at the receiver side. There is no equalizer at the transmitter. Sampler, channel encoder, source encoder. What else we have seen? Modulator, mixer, RF unit, frequency go. Good. Then channel, then receiver. It will capture the signal. RF down. Now that we see it, equalizer. Then the multiplexer, the modulator, the you receive the signal. So the equalizer is at the receiver side. Good. Abdullah, lost? What was the question? Ubaida, why you cannot then equalize the channel?
Because of good performance.
That's it. You have a variable h. You cannot equalize the system. Clear? Solution. What would you suggest to here to do? Hani. Is it clear the problem? The problem is clear. What do you suggest? Why? Very good. So the solution from your colleague is that here we have this one. So I will divide it into smaller ones. Each one of them, I can say it has a specific value. Okay, this operation is called slicing. Okay, and instead of a channel, so here one channel, you will have several n sub channels or sub carriers or sub bands. All of them are good. Good. So here you will transform your channel into sub channels, okay, through this slicing. Then here, where is it? You need to make slicing of the channel, okay? This is OFDM. OFDM stands for the O orthogonal, and then FDM, you know, frequency division multiplexing. What is multiplexing? What is the meaning of multiplexing, يا عبد الغني? وش بصير فيهم بعدين؟ Okay, good. Multiplexing means multiple users. Or frequency division, we divide the frequency. So where is the frequency division here? Where you see here, this is the frequency axis, so we are dividing the frequency. Good. Orthogonal because what is the meaning of orthogonal يا عبد الغني؟ بعد ما عملتهم هيك no interference. Good. So here حذيفة لا إذا هيك حمزة, what's up? All clear? You follow us? Good. So here, this OFDM, okay, it will help us to do this slicing. And we need the slicing, so we have to equalize the channel. So why we need to equalize the channel? Why it is non-equalizable? Because it is frequency selective. So why it is frequency selective? Because we had to increase the bandwidth. Why we had to increase the bandwidth? Because we need to increase the data rate. Motivation clear? So next time, okay, I will start with the OFDM. So here I will explain the OFDM. Before that, here there is a point that is also interesting. What will happen whenever one of the, this one, yes, actually here you see 0 is this one. Here the channel performance is equal to 0. That's it. First of all, you will not receive anything. Okay? And if you'd like to equalize, the system will go down, okay? Because you will reach infinity, 1 over 0. Good? So what to do here in a practical system? We have these slices, okay? So you will say receiver. Imagine that you divided the channel into 200 slices, okay? Here, this slice, which one number? 107. You say receiver, hey, this 107, forget about it. Because you will not be able to equalize. And this happens so many times. So whenever this is transmitting to any user, so many times, okay? Some of this, because we said the channel is random, changing over time and frequency, okay? Then it might face a scenario whenever its performance is close to zero, then that sub-channel is simply discarded. So even whenever they want to transmit, they have, this one has 47 subcarriers. So some of these 47, they are not used at a specific instance. So now 42 is not used. After some milliseconds, 19 is not used. After some milliseconds, all of them are used. After some milliseconds, 3 or 7 or 21 are not used, and so on. Good? But yeah, it will be much better than all the channel to be not used.
When we have h equals 0, we have a sharp or
The system, the channel is random, okay? So you can stand here next to it, okay, and some reflection going up to you, some other reflection going here and there, but they are added non-coherently. You know what is non-coherent addition? What is it?
non-coherent, like it's not the same thing at the same time. Coherent.
What does it mean, non-coherent addition? So maybe here you are receiving a signal that is 7, but with an angle of 0. From here it is 7 with an angle of 180. Whenever you add them, you will get 0. Okay, so yes, you receive power from the first, you receive power from the second, but if their angle is opposite, they will cancel each other. This is what we call non-coherent. Clear? So yeah, maybe it is normal that your channel is very close to 0. Good? Clear? Questions? No? Okay. We will stop here because we have something important. Yes. I have here the quiz tool to distribute, okay? Before that, I have another quiz. No. I'm sick. You can leave. Hani, what are you doing? No. كيف رجع راسك؟ خالد جاهز الكويز؟ سبتح لك بسدد. يلا flip the paper. Please don't write your name and number. This is a questionnaire. This okay guys. So this is first of all, don't write your name and number. I need it to be confidential. Okay, so write whatever you want. Focus on the negative aspect. Okay, so the university will ask you at the end of the semester to fill something online. This is for me. Okay? So whatever you write here, I can try to implement on the rest of the course or in future courses.
prepared something generic one.
But this is why I don't want to see your name written.
I would like.
Muhammad Hassan. Who is not here? Muhammad not here. Shab.
This quiz was out of how much? I don't know. 5?
10.
10? But you cancelled this question.
I'll tell you about it. Thursday night. No. Sorry. You can make a picture of your quiz if you want, because I will correct them. Okay, after you correct.
الكويز من 10 ولا من 15؟
It is out of 10, but there are 2.1. Sorry? I will talk about it later. I will talk about it. Wow. I like your t-shirt. Name and so on. Hamza. Yeah, okay, good. So, whoever finished, okay, please put back here quiz and مش quiz, the quiz and the questionnaire, and you can leave. If you stay, I will talk about the quiz. I will talk about the quiz whenever I will finish. When Hisham, I'll talk about it. معقول؟
والله حاولت
خلاص جميل. So the grades they should be posted today, but they should have been already posted. أحمد عبد الله.
You got 10. I got 10.
I got 10 also.
Yes, if you don't want to listen. So whatever I will say about the quiz. And you got the 10, right? Again, questionnaire and quiz. I will tell you about the quiz. So for the quiz, the grades are from check the key. Okay, where's the key? Now I have here the key. So for the key, okay, I expected it to be easy, but some of you got 0. Okay, good. So it is. This is the first question is out of 10. The second question is a bonus out of 2. So for the one that is bonus out of 2, you have to say that orthogonal and guarantee no interference. Okay, to get the 2 points bonus. Okay. For the 10, how to calculate it? First of all, here you have to calculate the number of frequency bands. So 125 bands. Then how many users they can fit? The 150 milliseconds divided by the 1 millisecond for each one. So 150 users. Then multiply them. The number is 18750 users. Distributed as 433. I saw some students, okay, making here number of users equals 125. 0. Number of times 125, 0. So even, so here some students here, some of you, okay, you got 125, but yeah, you have to show me, these are the number of bands so that I can continue. Otherwise, I wrote no sense.
Doctor, why are you not stopping the
Ah,
recording?
yeah.
You're embarrassing
Stop
us.
this band.
You want to stop the recording? Well, that is that.
You're embarrassing us right now like that.
After all, if I made a mistake